Okay, we are going to look at a game we played, well, not much of a game, but a simple one, where we were rolling die. So I actually put a little baggie out with the die, and each table had 4 die. 3 of the die were 20-sided, and 1 of the die was a 4-sided die. So the way you tell how the 4-sided die, which is the winner, whichever the bottom number that's touching the paper, so here, this bottom number is a 2, so that rolls a 2. And here the top numbers indicate what's rolled. So I said you get to count this as a 1 if you roll a 1, 2, or a 3. All right? So, and then we recorded from all of our people. We had, let's see, how many rolls were 20-sided? We had 150 rolls here, and we had 70 rolls there. So we had 22 students rolling die. Each one rolled it 10 times, and we recorded how many wins and losses they had. Now, how many total wins did I have? Well, I can just add these up. 4. And here I have 136. When I add all these together, adding this way and adding this way should give you the same number, and it does, 220. So we did a total of 220 rolls in class because there were 22 students rolling. All right, so looking at our rolls, what would you say is the probability of winning? Well, if I don't care what kind of die I need, I just need to know the total of wins, which would be 84. And out of how many rolls? 220, right? So that's the probability of winning. I can change that to decimal to make life a little easier. 84 divided by 220, and I'm going to do 3 sig figs, basically about 0.382. Now, what's the probability? This is the and symbol, in case you forgot. Rolling a 4 die and winning. Well, that's a fraction of the total, 220. And how many of them are wins from 4-sided die? And they're winning and using a 4-sided die. They're 48. And that works out to 48 divided by 220. Oops. 0.218. Okay, so that's the percent for a 4-sided die and winning. Winning a 4-sided die is the same thing. Doesn't matter which way I do it, it's the same. Now, what's the probability of winning given that I have a 4-sided die? That's a different question. So this symbol right here is given. And you read it, winning given 4. Okay. Well, what I know, when I say given 4, what that means is that I'm ignoring everything that's not a 4-sided die, because I'm given that I rolled a 4-sided die, right? So if I scoot these down just a little bit. Well, here are all the rolls with 4-sided die. Out of those, 48 were wins out of 70. So I can say 48 divided by 70 is 0.686. All right. The probability of winning given that I rolled a 20-sided die, so I'm looking only at these, would be 36 out of 150, which would be, let's see, 36 divided by 150, 0.240. Okay. Now I'm going to go ahead and look at this. I'm going to try and translate this table into a sample tree, because there's between sample trees and these tables. And the sample tree, sometimes you're given the information for a sample tree right off. So when we're doing a sample tree, the first thing we have to do is what probability do we have that we have a 20-sided, I'll just stick with, actually, 20-sided, or we have a 4-sided die. Well, we've got to look at what fraction of them, I usually like to put my numbers here, what fraction is 20-sided. So what fraction of the rolls are 20-sided? It's 150 over 22. So this is probability of a 20-sided die, 150 over 220. And I'm getting basically 0.682. So the probability that a student, if I were to take some random roll in my classroom, out of all this data, 68% of the rolls were done with 20-sided die. Now, the reason, actually, we'll talk about theoretical in a second. All right, now, if I look at this, what's the probability that they didn't have a 20-sided die? It would just be 1 minus that number. Or if I started with the fraction is 70 out of 220, right? Which is roughly 0.318. Okay, and those two add up to 1. Every time you're doing a sample tree, that little set of branches that all connect to the 1 point, all of these should add up to 1. Now, if I roll a 20-sided die, there's a chance I'm going to win or lose. Well, for sure I'm going to do one or the other, but the chance I'm going to win and the chance I'm going to lose. So what's the probability I'm going to win? Well, for 20-sided die, if I know I'm doing a 20-sided die, right, I have it right here. It's 36 out of 150.240. Right? That means that this one better add up to 1, because it's the only other branch. If I had 2 other branches, I would still need some more information. But I can also look at the table. Probability of losing is 114 out of 150. That better be like 2/3. Well, yeah, 0.760. Same thing for the 4-sided die. It also has wins and losses. All right? So looking at the 4-sided die, we can go ahead and what's the probability of winning when we have the 4-sided die? We already figured it out. It's 0.686. And the probability we lost with the 4-sided die should be 0.314. Let me double check. 0.314. All right. Now, what do you do for this? So what is coming out here? This represents 20 and winning. So if I want to figure out this probability, I multiply these two numbers. So I'm going to go 0.682 times 0.240. And I'm getting roughly 0.164. Now there's going to be some rounding errors, so this won't matter too much. It won't be exactly right. Probability I have a 20-sided die and I lose is going to be the product of these two numbers, 0.682 times 0.760, or 0.518. Now you might go, wait a second, Mrs. Overman. Let me put a line there so you know. Wait a second, Mrs. Overman. These don't add up to 1. Well, that's okay, because this is not all of the occurrences. I still have to look at 4-sided die. So this is for the entire, all the occurrences, all the rolls in my classroom. All right, so the next one would be the probability that a roll was with a 4-sided die and it was a winner. Multiply this, 0.318 times 0.686. And I'm getting 0.218. Then the probability it was a 4-sided die and it lost. .0998, so this is really 0.100. All right. Okay. Now, one thing you should always do once you've done all these calculations is you should go back and add all these numbers together. So I'm adding 0.164 plus 0.518 plus 0.218 plus 0.1, and I got 1. Beautiful. So that means I probably did a very good calculation. So if I wanted basically a sample tree can give you the and probabilities. You see that? So if I want to know probability of 20 and winning, I just look at the product out this branch. All right. You can also use sample trees to figure out conditional probabilities, like the probability of winning given it's a 4. So the probability, so we already did it up here with the table. Probability of winning given it's a 4, well, actually that's pretty easy, we already figured it out up there, is basically the same as the probability of winning and a 4. This is the formula all over the probability of a 4. So it's basically this product, 0.218, all over the probability of a 4, 0.318, right? And so if I divide those two out, 0.218 divided by 0.318, I got 0.686, which is the same. All right. I'm sorry, I was off screen. The interesting part is when I do a harder probability, which is probability of 4 given that I won. All right. So this is the one where people get tied up. Probability of winning in a 4, so the top number is still the same. But now I'm looking at the probability of winning. All right. So basically, it's going to be 0.218 on top. It's the same number both ways, because it's always the and on top. But what's the probability of winning? Well, there are two ways to look at it. I could go up here to my original table and say, oh, well, it's however many wins over how many losses. So I could say it's 0.382. I could do that. All right? And if I go ahead and calculate that, 0.218 divided by 0.382, I get about 57%, 0.571. All right. But here's an interesting thing. Look at the winnings. This one won and that one won. If I added those two numbers together, 0.164 plus 0.218, what do I get? I got the same thing, the 0.382. So you can actually either use the table for a conditional probability, and I think the tables are intuitively easier, or you can actually just use a sample tree. And I'll give you an example of why you might want to use a sample tree.